Hello everyone, welcome to our fifth lecture in elementary physics. And in this session, pag-aaralan natin ang momentum and collisions. So our objective for today is learn about the concepts behind momentum and the physics behind collisions. So let's start our discussion with linear momentum. So this first part of the lecture will grasp on the basic concepts involving momentum. When we say momentum, it is a vector quantity equal in magnitude to the product of its mass and its velocity. So it is defined by the product of the mass, which is a scalar, and its velocity, which is a vector, and therefore the momentum is also a vector quantity. So technically speaking, suppose may object ka dito, may velocity siya pag ganon, may mass siya, therefore yung kanyang momentum the same direction as the velocity, and yung magnitude niya is the product of this velocity and this mass. Okay. So ang unit natin for momentum is kilograms meters per second. Yung mass is in kilograms and yung velocity is in meters per seconds. Next, meron tayong tinatawag na impulse. Impulse is a vector quantity equal in magnitude to the product of its force and the time interval in which it acts. Its direction is the same as that of the force. So, ang impulse natin, which is a vector quantity, is equal to the product of the force, which is a scalar, and the change in time, yung force is a vector, and change in time is scalar. So, suppose meron kang object dito and you applied some force, kamay mo yan, or paa, I don't know. You applied some force, we'll say that's F, within some time interval, delta t. That force is equal to the momentum this object experienced from your applied force. This equation only works kapag yung force mo is constant. However, you can still find the impulse of non-constant forces by using this alternative formula, which is the antiderivative of the force function with respect to time from the initial time t naught to the final time t. So, pag titingnan natin sa graph, ito yung non-constant force mo, ito yung area beneath that curve is your impulse. And kung titignan naman natin sa isang constant force, syempre, to some time interval t, delta t, yung area dyan is just equal to yung original formula natin, which is F delta t. Now let's relate the impulse to the momentum that is the main focus of this lecture. So by the impulse momentum equation or the impulse momentum theorem, this states that the impulse that is experienced or that is applied on an object, experienced by the object or applied on the object, is equal to the change of its momentum. So by symbols, it's J. Wait lang. Magsulat ka. It's J. Matanda mo eh. Anyway, that's J is equal to the change or delta of the momentum P. Where J is the impulse and delta P is your momentum. Delta P being M times delta V. Delta V being this equation, this expression. So, sabihin natin, i-visualize natin siya. Suppose kanina, di ba, at rest yung object mo. Then, you apply the push. Ang object mo at rest, so its initial momentum is 0. Then, you applied some F delta T. That's an impulse. It will then move. may motion nang nangyayari sa kanya. And that motion has a momentum P equals to the mass and its velocity, which is equal to the impulse that you applied upon that object. Okay? So, yan yung impulse momentum equation. How about kung may motion na yung object? So, sabihin natin merong ball, ito yung ball. Meron na siyang P equals to M times V sub 0. Tinamaan niya to. So that wall applies a force within some time interval according sa third law of motion. That ball will then move to the opposite side or to the other direction with velocity m, with momentum m times v. So yung m times v minus m times delta v sub 0 is equal to f delta t. So yan yung impulse momentum equation. Sinasabi lang yan yung impulse is equal o yung impulse na in-apply mo sa isang object is equal in magnitude dun sa change ng kanyang momentum. So let's see these in action. For our first problem, assume that the 8 kilogram mass moving to the right at 4 meters per second collides with a 6 kilogram mass moving to the left at 5 meters per second. What is the total momentum before and after the collision? So, ang pinaka-fundamental thing na ginagawa dito is to list your events. So, sabi dito meron kang 8 kilogram mass, which we label M sub 1. That's 8 kilograms. And meron kang mass, second mass, we will label it M sub 2, 6 kilograms. Your M sub 1 is moving to the right at 4 meters per second, while your M sub 2 is moving to the left at 5 meters per second. So, suppose may ganyan ka, ito yung M sub 1 mo, ito yung M sub 2 mo. Since it has opposite directions, we need to assign signs for its direction, or for its velocity. When we say it's moving to the right, sasabihin natin positive yung kanyang velocity, while it's moving to the left, negative ang kanyang velocity. So since yung 8 kilogram mass is moving to the right, it has a positive velocity of 4 meters per second. Wherein yung second mass naman natin is moving to the left, so it has a negative velocity of 5 meters per second. Now we are finding the total momentum before and after the collision. So to find the total momentum before the collision, that's just equal to the momentum of mass 1 and the momentum of mass 2 added together. Okay, so that is any momentum of 1, that's its mass times its initial velocity, plus for mass 2, that's mass 2 times its initial velocity. Ano yung mass 1 natin? That is 8 kilograms. And it has a velocity of positive 4 meters per second. Plus, ano yung mass natin? That is 6 kilograms times its initial velocity of negative 5 meters per second. When you evaluate this, you will get a total momentum before the collision of 2 kilograms meters per second. So that's our answer for the first part of this problem. We found the momentum before the collision. How about after? Well, wala naman sinabi. But we do note that the total momentum of a system is conserved. Meaning to say that the total momentum after the collision is equal to the total momentum before the collision, which we will discuss more on the second part of this lecture. Kaya naman, ang total momentum after the collision is also the same as yung na-compute natin, which is 2 kilograms meters per second. So that's the answer for our first problem. Okay? So in-add lang natin ang individual momentums ng object to find the total momentum of the system. Now let's proceed to the second problem. The head of a 3 kilogram sledgehammer is moving at a velocity of 14 meters per second as it strikes a steel spike. It is brought to a stop in 0.02 seconds. We need to determine the average force on the spike. So again, let's list the givens. We have m sub 1 equals 3 kilograms. And sinabi dito, it is moving at a velocity of It is moving at a velocity of 14. So wala na to. Wala na rin pala to since isa lang ang ating mass. So it's moving at a velocity of 14 meters per second. Then, does it have a final velocity to deal with? Probably wala. Probably meron. What do you think? Well, our answer is meron. Sinabi dito, it is brought to a stop. Therefore, anong stop? 0 meters per second. In some time interval delta t, which is equal to 0.02 seconds. We are finding the force on the spike. Okay. So how do you find the force on the spike? So visualize muna natin ang problem. Meron tayong sledgehammer. I don't know yung tsura, pero parang ganyan. Then meron tayong like a spike dito. So, di ba? When it strikes this spike, yan. Mangyayari sa sledgehammer is magkakaroon ng change in momentum papunta sa direction na ito. So may siyang change in momentum. Therefore, this is also equal to its impulse applied on that object, which is equal to the force times the time interval. We have the force here. That is the force acting on the sledgehammer. How do you find the force acting on the spike? So by, again, third law of motion, yung force acting on the sledgehammer is equal in magnitude to the force acting on the spike. So technically, we're just finding this letter F here. So through the impulse momentum theorem, we say that the impulse applied on the sledgehammer is equal to its change in momentum. So ano yung impulse? That is F delta T. Since constant force naman to, or average force yung nahanap, is equal to M times delta V. Divide both sides by delta T to isolate our letter F. So we have F equals the mass. Ano yung mass niya? That is 3 kilograms times delta V. So ano yung delta V? That's final velocity, 0 meters per second, minus initial velocity, which is 14 meters per second. Divided by, delta T, which is 0.02 seconds. So the force is equal to, by this computation, it's negative 2,100 newtons. Which is, nag-show lang siya na the negative shows opposition to its force or to its motion. But technically, the force is just equal to 2,100 newtons. Yan na yung force on the spike. Ito negative just shows that it opposes the initial motion. Okay, so here's our answer for the second problem. Now let's proceed to the third problem. For a third problem, a 0.30 kilogram softball has a velocity of 15 meters per second at an angle of 35 degrees below the horizontal just before making contact with the bat. What is the magnitude of the change in momentum? Again, change in momentum of the ball while in contact with the bat. If the ball leaves with a velocity of letter A, 20 meters per second vertically downwards, and letter B, 20 meters per second horizontally back towards the pitcher. Okay. Para dito i-visualize muna natin ang initial condition. So this is the initial. Initial. So meron daw tayong softball dito. Ito yung softball. Then it is moving at a velocity with the angle of depression of 35 degrees. But angle of depression below the horizontal. So that velocity is 15 meters per second. And para ma-use natin ang conservation of momentum, kailangan natin i-bisect yung mga velocities into its x and y components. So, let's say that yung sa x component, yung papunta sa right, yung positive. While yung papunta sa left, yung negative. While sa y component, yung papunta sa taas, yung positive, pababa naman yung negative. So, etong 15 meters per second, 35 degrees down the horizontal, meron siyang x components, which is this. Let's label it u sub x. And meron siyang y component, which is this. Let's label it u sub y. How do you find these two vectors? So, u sub x is equal to, tanongin natin, is it moving to the left or to the right? It is moving to the right. Therefore, it has a positive direction. So that's positive. Ano yung, how do you find the quantity or the magnitude of that vector? Remember, sa trigonometry, this is a adjacent side to the angle. Therefore, we will use 15 cosine of 35 degrees. So what is 15 cosine 35? That is 12.29 meters per second. On the other hand, meron tayong u sub y. Ang u sub y ba natin is moving upwards or downwards? It is moving downwards. Therefore, it has a negative velocity. So it's negative. Then it is at the opposite of the angle. Therefore, we will use 15 sine ng angle 35 degrees, which if you evaluated is negative 8.60. Ang unit niya is meters per second. Okay. So yan yung initial condition. Now let's deal with the problem. For letter A, we are finding the change in momentum when the ball leaves at the velocity of 20 meters per second vertically downwards. So yung ball daw, after being hit, this is the final condition, it's moving downwards at 20 meters per second. Therefore, ano yung v sub x at v sub y natin? V sub x and v sub y. Sorry. So, ang v sub x natin is, since wala siyang x component, we will label 0 meters per second. On the other hand, yung v sub y natin meron, it's going downwards, so negative, that is 20 meters per second. Okay. So to find the change in momentum, we should first find the change in velocities for both x and y components. So to find the change in velocity, we will find the change in velocity in x and y first. So ang change in velocity sa x-axis, that is v sub x minus u sub x. So that's equal to ano yung v sub x natin, that's 0, minus ano yung u sub x, that is 12.29. Therefore, your delta v sub x is negative 12.29 meters per second. Ngayon, hanapin na natin yung delta v sub y. Ang delta v sub y, same lang dito yung change, that is v sub y minus u sub y. So, ang v sub y natin is negative 20 minus ang u sub y, that is negative 8.60. So, that is equal to negative 11.40 meters per second. Okay. Ngayon, to find yung change in momentum, that is equal to the mass times change in velocity. And to know what is the change in velocity, that is the sum of the components ng changes. So that is m times the square root of the sum of the squares of these two. So that is delta v sub x squared plus delta v sub y squared. Okay. So that is ano yung mass? That's 0.30. Ano yung v sub x squared? That is negative 12.29 meters per second quantity squared plus ano yung v sub y? Negative 11.40 meters per second quantity squared. Tapos naka-square root yan. So ang delta p natin for letter A, that is 5.03 kilograms meters per second. So that's for letter A. Letter A pa lang yan. Medyo mababa, di ba? Okay, for letter B naman. So this is for letter B. Same initial condition. So susunod na lang natin yung nakuha natin kanina. Ano yung initial condition? We have v sub u sub x equals 12.29 meters per second. Sorry. And u sub y equals negative 8.60 meters per second. Ngayon, let's find the final condition. So that's F for letter B. Meron siya, ang sabi dito is 20 meters per second horizontally back towards the picture. So, ganyan yung ano niya, ito yung ball. Then going horizontally back towards the picture at 20 meters per second. So, does it have a u sub x? Well, since pa-horizontal siya, that is pa-left siya, diba? Not pa-right. So, since pa-left siya, that is gonna be negative. Then yung velocity, that's 20 meters per second. Tapos yung u sub y naman, since wala naman siyang y velocity, that's 0 meters per second. Now, same procedure, hahanapin natin yung delta v. So, delta v sub x, that is v sub x minus u sub x. That is equal to ano yung delta, ano yung v sub x natin? This is not u, oh my gosh. This is v. I'm so sorry. Anyways, ang v sub x natin, that is negative 20 minus ano u sub x, that's 12.29 So, ang delta V sub x natin is negative 32.29 meters per second. Meron naman tayong delta V sub y, which is V sub y minus U sub y. Saan yung V sub y natin? That is 0. Minus ano yung U sub y? That's negative 8.60. Am I getting it right? Yeah. So that's equal to 8.60 meters per second as the change at y velocity. And therefore, to find the change in momentum, we'll use the same equation, which is m delta v, which is equal to m times the sum of the squares of the components taken as square root. Okay, so that is 0.30 times ano yung v sub x, that is negative 32.29 squared plus 8.60 meters per second quantity squared. Then take its square root. Ano yung delta P? That is equal to 10.0 kilograms meters per second. So that's our delta P for letter B. Okay. So ang ginawa lang natin, we find the changes in velocity for both x and y components of the velocities. Then hinanap natin itong delta P, which is equal to the product of the mass and the change in velocity. Okay, let's deal with the next problem. For problem number 4, a 0.25 kilogram pop is initially stationary on an ice surface with negligible force, friction. At time t equals 0, a horizontal force begins to move the pop. The force is given by F equals 12 minus 3t squared at the x-axis, and it acts until its magnitude is 0. For letter A, what is the magnitude of the impulse on the pop from the force between t equals 0.5 seconds and t equals 1.25 seconds? And letter B, what is the change in momentum of the pop between t equals 0 and the instant at which F is equal to 0? So let's deal with the problems now. So for letter A now, we are finding the magnitude of the impulse. Okay. So meron tayong F as a function of time, that is 12 minus 3t squared. And we're finding the impulse J. So recall kanina that for non-constant forces, we will use the formula for J, the antiderivative of the force function with respect to time from initial time to final time. So meron tayong function which is 12 minus 3t squared with respect to time. So that's dt. From t, ano yung initial condition niya? That is 0.5 seconds. Ano yung final condition? That's 1.25 seconds. Okay. So if you take the antiderivative of this function, that's gonna be 12 e minus t cubed from 0.5 to 1.25. So kung nag-take ng basic calculus pang walang c, we don't include that here. Since definite ang ating integral. So evaluate this, that's gonna be the quantity 12 times 1.25 minus 1.25 cube subtracted by the quantity 12 times 0.5 minus 0.5 raised to 3, which is equal to our impulse, which is 7.17 Newton seconds. So that's our answer for letter A. For letter B, again, we have the same problem. We have the same force function with respect to time. And we're finding the change in momentum. So by impulse momentum theorem, we know that the change in momentum is just equal to the impulse on the object, which is defined earlier as the antiderivative of the force function with respect to time, from initial time to final time. Ano yung force function natin? That is 12 minus 3t squared from dt from ano initial time na binigay, that's 0 to the time at which f of t is equal to 0. So, hindi natin alam actually. Wala namang binigay na time dito. However, we can solve for that time t. So, remember that sa condition na ito, it's f is equal to 0. So, ano yung force function natin? That's 12 minus 3t squared is equal to 0. And extract natin ang roots. That's going to be negative 3t squared equals negative 12. And divide both sides by negative 3. That's going to be t squared equals 4, yielding a t value of positive or negative 2. Okay. Since hindi naman after ng t equals 0 yung negative 2, we'll disregard this value and therefore we'll only use the positive value, which is 2. Okay. So evaluate the integral. That's just going to be 12t minus t cubed from 0 to 2. So, ano yan? That's going to be quantity 12 times 2 minus 2 cubed minus quantity 12 times 0 minus 0 cubed. So these 0 values are cancelled, just 0. And we have this, which is equal to 16.0. And our unit, since delta P siya, that's just going to be kilograms meters per second. And that's our answer for letter B of this problem. So that's it for the first part of this lecture. Our next part will be about the conservation of momentum. But for now, let's end our lecture here.